All right, let's get started. Hello, everyone. Welcome to ITS 365. We're going to get started in recording the session. I'll be posting these videos on YouTube so you guys can take a look at them. Yeah, so we need to do the initial course participation. So today I'm going to do the syllabus and get started with the course, which is Machine Learning Foundations. So most of the materials, or your starting point, I should say, is going to be Brightspace. So that's where you can submit your homework assignments, essentially, and then where you can see your grades posted. And then I'll provide links to other resources that we're going to be using in the course. So the course, you guys are 365.001, right? So section 1, I believe, is on Mondays. I posted the materials, so you should have all this available to you now. If you go to table content here, this is where I usually load all the materials. So you just click on table of contents. I have loaded the materials already, but I may change some of these, add materials to them. But in general, this is where you can find everything. So everything has been posted from beginning to end. Essentially, I don't go by like, say, week 1, week 2. Instead, it's modules in sequence, right? Because one module could last 2, 3 weeks versus there could be 2 modules in 1 week. It just depends on the topic. Okay. So yeah, so that's the course. It's your first machine learning course. I know you guys have taken 265, which is your Intro to AI course. So that has covered some of those topics. This one, AI is broader. Machine learning is a subfield of AI, right? So essentially, machines are learning. That's the idea here. So that's what we're going to look at. It's essentially a whole bunch of algorithms. So I'm sure when you took data structures or something like that, or if you'll take it, you look at specific algorithms for the individual data structures. For instance, sorting, right? So we're all familiar with like a sorting algorithm of some kind. Or if you're taking a cryptography class, so there's algorithms on how to encrypt things. So this is similar. There's algorithms for machine learning. And the great thing about this is essentially there's like, there could be 50 to 100 algorithms, but for the most part you need 20 to 30 of them. So think of it as once you learn them, that's it, right? So you just understand how they work. And the key challenge is always going to be that you have some data set, right? And so we have to learn how to take any problem, take the data from it, format it, fix it, clean it up, and then put it in a specific format that we're going to call CSV format, or I should say the vector space model format. And that's going to go into our algorithms easily. So once we put it in that format, it almost goes into a lot of the algorithms, right? And so another thing that we're going to learn is that there's algorithms for different types of problems, right? So let's say you want to predict sequence, right? So not only predict the stock market today, but tomorrow, Tuesday, Wednesday, Thursday in sequence. And the prediction for Thursday depends on the prediction of Wednesday and Tuesday. Do you see that? So that's a specific type of an algorithm, sequence mining type of an algorithm. There's going to be algorithms where we're just classifying, right? So we have a picture of a cat, picture of a dog. We want to learn how to teach a model to learn how to classify that as a cat or a dog. Or we want to predict an actual value like housing prices, right? Or we want to build a little agent that actually plays a game, right? So it's different kinds of problems. And so that's the idea. So I'll go over the syllabus today. These are some of the topics. Um, there's a grad level course, ITS 520. Both of them have kind of their introductory, but that one is more advanced algorithms. This is more lower level algorithms. So there is a bit of overlap, but not super overlap. So you'll see that. Yeah, and so one of the things that's fun about this course, there's going to be a competition at the end of the semester, so I always do that. And there's also you learn how to deploy the models, right? So we're going to learn how to deploy the models with various methods. Fast API is a new one that I've been working on. Streamlit also, and there's Onyx. So there's several ways that we're going to be doing that. So you'll be able to build web applications that have AI in them. And you guys, being IT students, cybersecurity students, you all know web development in some ways. So that is going to tie in to that. All right. Yeah. So, but yeah, machine learning. I'm sure you guys know about all the things with AI and ChatGPT. We're not going to cover any of the advanced algorithms of ChatGPT, like LLMs, things like that. So those are much more advanced. We have more advanced courses for that. All right. This is definitely an undergrad level introductory course to machine learning, but actually you get to do quite a bit. We will cover deep learning, a little bit of transfer learning towards the end. In fact, the competition has two phases, phase one and phase two. In phase one, you cannot use transfer learning, and in phase two, you can use transfer learning. So it should help you to understand the differences and the how AI works today. All right, so yeah, so that's the idea. So let's go over the different modules just to get a feel for them. So admin, this is going to be where the syllabus is, so I'll go over the syllabus today. Projects and surveys, so I'll discuss, kind of some ideas of projects, the project description that we've done in the past, and I may change that this year. Resources, this is an important one. So obviously I'm recording this this lecture as a YouTube video, so I'll be posting that video on here, right? So you can just click on this and just look, make sure you make a note of, what the topic is. Usually I'll post them on the day or, within a couple of days of when it was filmed. So just look for it. GitHub, obviously this course does include a lot of code. You're not usually coding from scratch, right? So that's not like the goal. But you do have to understand the code that you're reading, right? So you have to understand all the code is in Python, but with a lot of libraries that are involved, and we're going to learn some specific type of math operations related to machine learning. So that's one of the key things. Yeah, so the code is going to be on the GitHub, which should be on this machine learning foundations, and you can see I have all the different techniques. Let's go back. All right. Yeah, and then there's going to be a materials section that I will post sometimes, like a blog post, etc., of different descriptions. So you'll see that. So in particular, the two links that are really important here in resources are the YouTube channel and the GitHub. Definitely make sure you use those. If you see me working through code, don't worry. The code that I'm doing in class is already posted on here, so you're not going to miss anything. But definitely focus on understanding. And remember, I may do an example with a data set, but when I give you the assignment, it's going to be, thank you. When I give you the assignment, it's going to be an entirely different data set, okay? And so, yeah. So some of you guys are cybersecurity students, so one of the things is I need to do some cybersecurity related data sets, so we're going to go over that as well. And that should be pretty easy. What you'll learn is, honestly, is that once you have the data in the format that it's supposed to be in, it's very easy to do the machine learning. You'll see that. But the hard part is, and the thing I can't teach you to do, honestly, because it just depends on the data set that you're using, is how to go from data to a file in that format. So we're all familiar with Excel, and a lot of our files are going to look like that, like one sheet in Excel, which you're probably familiar with the term CSV, right? So comma separated file, that's kind of the default format. There are others, but that's going to be usually, and that format captures an idea called a vector space model, which is really important, and we will cover later. As far as GPUs, we are going to be using GPUs. Thankfully, nowadays we have Colab, right? So hopefully some of you are familiar with Google Colab, and you know that that it used to be a bigger problem before in the past to get GPUs. Now it's pretty easy. For everything that we're going to do in this class, Colab should be more than enough. It's very powerful. So you'll need to create a Google account. You'll need to create, get on Colab. If you have a Gmail account, that probably works. You will need Google Drive, right? Your own Google Drive, your own personal drive. That's actually very powerful, and you can load really big data sets. So, images and color, 70,000, 100,000 images, and it'll process them fine. And there are more efficient ways of actually getting the data into Colab, but that's one way. All right, so definitely get a Google account, and I'll show you Colab today. That's one of the things that I'll demo. Should be pretty easy. Then we can see we've got matrices, vectors, and NumPy. So we'll be using a lot of libraries, NumPy, PyTorch, etc. And understanding matrices and vectors is essential for machine learning. So in 265, you should have covered a little bit of this already. So they, NumPy for sure, and they showed you a few operations of vectors and matrices. I'll kind of do the same, a review of it. This is critical, right? So it's a sort of a field from linear algebra, but you don't need to know all of linear algebra to do this. This is just like a type of operations that makes things more efficient, right? So the reason why we use it is that it's faster, is more efficient. So the alternative would be terrible, right? So programming, usually the alternative is doing everything by programming 2 for loops and then iterating through little arrays, right? 2-dimensional, 3-dimensional arrays. That would be not fun, right? So instead using these approaches, it's much more efficient. So I have a set of like 70 problems that I'll give you as a review, and that's important that you go through those, okay, and understand them. Just do them mechanically. Do them, repeat them, do them a third time, right? And eventually the mechanics of it are going to click for you, okay? Then we get into the actual theory, machine learning pipeline, feature engineering. So this is important to understand how to tackle problems. Then we'll start, the way that I like to start is with a tool called Weka, all right? So which is this one. So it's a very, this tool has been around for 25, 30 years, but it's still pretty good. It's got a lot of machine learning algorithms in it. It's totally GUI, right? So no coding for this one time. But what I like about this tool is we can take several data sets and just process, do all the machine learning and get a really quick understanding of how it works. So there will probably be a homework assignment also related to Weka. But we'll see that tool. That's a tool that you can learn how to use in an hour to 2 hours, and you'll see very quickly how to do. You'll be able to do machine learning really quickly, right? So you won't be doing the more advanced things like deep learning, but you'll see its functionality. Then after that, we will get into the specifics of the curriculum, the algorithm. So we'll start coding our machine learning algorithms, right? So that's the idea. You will learn how to code machine learning. Not every machine learning algorithm is going to be a neural network in this course. So this course actually is where we try to cover other, although we do cover neural networks, but we do cover other algorithms. KNN is one that I like to start with. We'll start with the perceptron. Historically, this is a neural net, the first one. So we'll start with this. We'll look at things like Hopfield networks, which can be used for intrusion detection type of thing, anomaly detection. We will look at some neural nets, performance metrics. We'll cover the basic algorithms of linear regression, and logistic regression, which are all kind of like traditional machine learning. And all of these, by the way, are available in Weka. So first we'll do them in Weka. You'll get a feel for it, and then we'll go into the individual aspects of them. Cross entropy, mean squared error, all of those techniques for optimization are also going to be part of the curriculum. Okay. Then we will cover some deployment tools, and I haven't loaded the Fast API module yet, but I've completed that one and it does work. And so that'll be one of the homework assignments that I will give you guys, which is really nice because you can deploy, you know, with Onyx, which is a nice one too that we will cover. You create a model, a static model, and you deploy it to the web. The nice thing about Fast API is that it's like you have the code and you can run the code, right? So you'll be able to run a script that you have running on a server, and then maybe you have a website, and the website just runs that on the server, the whole code, and then gives you an answer. So it's kind of a little bit different approach, but it's got its advantages. So that's, you'll see that contrast. We'll cover then some of deep learning, some of the basics of deep learning, and then we'll cover a little bit of transfer learning also, which is the idea that there are models that it's just too hard to train by ourselves, right? So something called a ResNet would be very difficult to train with 1.5 million images. We just don't have the resource, but thankfully, someone else, Google, Meta, they already trained it for us. So we're going to get a ResNet that is already pre-trained by Google, etc., and we can use it, deploy it. And the advantage of that is that, maybe you can train a model from scratch up to 100,000 images and 5 layers. But this ResNet would have 50 layers, and it was trained with 1.5 images. Do you see that? And on 1,000 categories instead of 10. So the thing that you can build from scratch, there's a limit, like, a plateau. After that, you really need, 1,000 GPUs, other skills, right, to be able to build a model. But with transfer learning, we can borrow someone else's model and use it. All right, and that's why I was saying in the competition, we can do this where in phase 1, I'll give you some data set, and you build a model from scratch, and let's see who builds the best model. Right, that's kind of, and that'll be towards the end of the semester, or at least I think the second, third, and then you get 80% performance. But then you use transfer learning, so you're borrowing someone else's model, a ResNet 50. Someone uses a vision transformer or whatever the latest thing is today, and they get 91%. You see that? So you squeeze out a little bit more. So you'll learn this idea. Everything in machine learning today is competition, right? So everyone, Google, Meta, etc., they have competitions, some data set, and then they bring in their models, right? And they try to outperform each other. Okay, and so that's the idea. So we're going to follow that same approach, and that's every semester that's been a fun project that we do. Okay. Yeah. So we're going to learn a little bit about calculus. The classic XOR problem, and some of the challenges that motivates why neural networks are sometimes more important or better than other methods. And keep that in mind, right? So you're learning all these methods like KNN, etc., Bayes, and several others, but they have limits, right? So, and that's one of the things that we'll be able to see. So for instance, one of the parts of the assignment with Weka is that I'm going to ask you to use multi-layer perceptrons, which are a type of neural network, not a deep neural network, a smaller type of a neural network. And hopefully Weka will work, but you'll see that it'll take a very long time to train. So you will see, like, what it felt like 15 years ago when you had to train those models, right, that weren't programmed the right way. And so then we'll switch to PyTorch, and you'll see that same model runs much faster. Okay. We'll cover unsupervised learning and k-means. So this is another type of algorithm, naive Bayes, reinforcement learning as well, and any other algorithms that I can think of. Okay. There's many algorithms. I can't cover all of them, but I'll try to cover some of the more important ones, and the ones that provide a contrast. What's the difference between one or the other? Any questions so far? As far as homework, there's not gonna, I'm not gonna assign a homework every week. This course will have, homework every few weeks, but the homework is more involved, right? Make sure to do the assignments. This is really important. We will do presentations sometimes, right? As this is the easiest way to see your performance, um, and so on. All right, so that kind of motivates a little bit of it, just really quick. Let's go over the syllabus, get a feel for it, for more of the details. All right, so here we are. So this is ITS 365, as I said, Machine Learning Foundations. We're in the spring 2026. I'm Professor Calix. I'm in Anderson 238. That's my email and number. Office hours are Monday and Tuesday before this class, 1 to 2. And then on Wednesday, 4 to 6, 4 to 6. All right. So I'll update that. But yeah, so those are the office hours or by appointment. So if you can't, you got to send me an email and I'll let you know if I'm in my office or not. Usually I'm in my office in the afternoon, so that would be the best time. All right. So let's go over this. So the course description, so this is really important. This is kind of the thing that we focus on. So this course provides a basic introduction to the machine learning pipeline and related concepts. Okay, and when I say machine learning pipeline, I do have a slide for that. You'll see what I mean. But it's essentially from identifying that you have you work at a company, maybe in cybersecurity, and you're like, how do we automate this process, right, of detecting a network attack? How do we even begin to do that? So that's what I mean by the pipeline. From there, all the steps with the remember, it's always about the data. 80% of the code is the data, right? Dealing with the data, converting that data, loading the data, processing it, etc. And then you'll see the algorithms will become straightforward. Okay? I mean, sometimes they're very, very new, and so you just kind of shocked by the how it is. But once you master it, it changes very little. It takes a long time to invent one of these algorithms. If you think about it, like the transformer was invented in 2017, right? And since then, and it took a while, it took years. The ResNets that we will use took 10 years to perfect. Do you see what I'm saying? So every couple of years, what if we add this? In competition, they saw that consistently it improved. So it took 10 years to build like the perfect setup for it. Adding something called a residual, adding all these individual components, normalizations between the layers, etc. So that's the kind of thing that you have to understand, right? Which will become pretty by the end of the semester. I'm sure it'll be very clear to you. All right, but yeah, so the machine learning pipeline is the idea. So processing the data to a certain point, certain format, feeding it into the algorithms, and then you evaluate performance. Okay. So that's also the nice thing about this class is that immediate feedback, right? You build a model, boom, 32% accuracy. That's kind of bad, right? So either you did something wrong or the algorithm just can't get better. So you're gonna, with Weka, for instance, I'll show you guys how to quickly, like really quickly, you can benchmark a data set with several algorithms and, from there start becoming more specific. All right, some of the topics covered include machine learning uses and applications, data set requirements, which, like I said, dealing with data, data pre-processing, which there's several steps for that, and I should say we'll cover some of that. Singular value decomposition, principal component analysis, and feature ranking. So those are important ones. Data annotation. Okay, so this is when you just have a data set. Let's say you have network attacks, right? So you have to what is called labeling, and you have to say, well, this is an attack, this is not an attack. Or you just have a whole bunch of images, right? And you want to classify them, so you have to annotate them, right? And say, so for instance, all of you are actually annotators. All of you. All of you are like professional annotators, and you've been doing that for 10, 15 years. Do you know why? Because all of you are on social media, right? All of you are on Facebook or maybe TikTok or whatever it is. And what do you do on Facebook, on TikTok all the time? You look at your friends' pictures and you go, like, don't like. This is a great cat or whatever. Your cat looks great. And doing that, what you're really doing is you're working for Meta, Facebook, what's the other one? Twitter for free. So they're getting all your labor and they've been getting it for 10, 15 years for free. And so you annotated all this data, and thanks to that, they're able to train these massive models that are really good. So you've all given a lot of your intellectual knowledge plus your time for free to these companies. And this is fact. And so, yeah, and that's the reality of it. And you keep doing it, and you'll keep doing it because they offer that service for you, right? That you probably enjoyed of social networks, but you are producing this. And so this will make more sense as we start to build the models. You'll see, okay, we need labels for this. How do we do it? Well, we need to annotate it. So sit down and go over all these images, provide the labels, and then you'll realize, man, this took me 10 hours to do. And so how much work, how much of your free labor have you provided to Meta? So anyway, so yeah, annotation is really important. So we'll talk about those concepts. Validation, data representation format. So this is key. This is probably one of the most important things in this class, right? Is, in terms of actually solving problems, this is the key, right? So you can understand the algorithms, 70% of them, right? So you have like certain understanding of it, but this is key, that you should know how to take a problem, take raw data, convert it into a specific format, and then be able to use that data to train a model that actually works. Okay? So we'll look at that. Features and feature representation and extraction. So these are some ideas of essentially and I'll talk about this today. How do we, take a problem, extract certain aspects of the data that represent that. So essentially, it's like if you've ever heard of sampling, right? So you're going to sample from, I look at these glasses and I don't need all the information about these glasses, just some information, right? And so you need to learn how to pick that data, and that'll become something called features. We'll talk about the vector space model. This is, like I said, a key concept that we'll talk about throughout the semester. Here you can see traditional machine learning algorithms. So that what I mean usually by this is I mean non-deep learning, right? So we're going to divide the machine learning algorithms sort of into traditional and deep learning. Okay, and deep learning will be the more modern things that resulted in things like ChatGPT, for instance. And then the traditional machine learning algorithms are going to be, non-neural network based algorithms, but they're still pretty important, as you will see. We still can solve problems with them. All right. So you can see traditional machine learning algorithms, and programming. So there is, all of this will involve coding. Evaluation methods is very important, so we will cover that, how that works. There's various metrics that we can use to assess and evaluate a machine learning model. And then introduction to deep learning. So deep learning is quite a extensive area, so we're only going to start very basic things. So you'll learn how to build a deep neural network, basically maybe a CNN, a very simple CNN for images, and that's it. But, we have more advanced courses on that. But, this should give you the foundations, as I said, of the topic. Other types of algorithms, reinforcement learning, we'll cover that. Reinforcement learning is really nice, actually. So it can be a course in itself, and it relates to games, right? So it's really nice in that way, robotics, things like that. Unsupervised learning and other special topics, as you can see. Although I haven't mentioned it, transfer learning is one of them. Okay. All right. Any questions about the course description? Okay. questions? All right. These course objectives are just a little bit more specific on some of the topics, but it's pretty much what I've just said. As far as the prereq, so you've all taken programming, right? So you've taken some kind of a programming course. I believe you guys are all juniors, right? Third year. So you've taken quite a few coding courses of some kind. As I said, this is not really a coding course. I'm not teaching you to, code from scratch. You just have to understand the algorithms. Like the algorithms have a specific idea, right? And you just have to understand it and be able to modify them. And just check my GitHub is full of code examples. This is a 3-hour course, so an hour. It starts at 2, it'll end at 3:40, and that's your every day, Monday and Wednesday. As far as books, there's no required book. However, if you want to get a book, probably Python Machine Learning by Sebastian Rashka. You just get the latest edition. Usually my code examples, everything are very consistent with everything going on there. So you can use that as reference if you want to get a book. All right. If you don't want to get if some people like to read books, right? So if you don't want to get a book, just I'll provide like a blog post type of, notes that you can read through, my own explanations of things. So you can use that as well. And I'll provide all the materials necessary. Obviously, I'll lecture and things like that. Any questions? But if you want to get a book, this is definitely a good book. I mean, just get the latest edition. And he's got several ones, so go with something like Practical Machine Learning. Or, sorry, Python Machine Learning. All right. So I'll provide the materials. I already gave you the links. As far as the grading, so there's a project that's 20% of your grade. Participation is 10% of your grade. So participation means regularly attending class, civility in the classroom, working with your teammates and everything, things like that, right? So that's what it means. You don't have to attend every class, but please don't miss every class, right? I post the videos for every class to help you out, not so that it becomes an online class, right? So, but I will try to record as much as I can just so that you guys can always just look back on something. Exams, there will be 3 exams. Each of them is worth 10% of your grade. So there's going to be an exam on week 6, an exam on week 12, and an exam during finals week. So this is obviously week 1, right? So we're on week 1. Okay, and then assignments are going to be 40% of your grade. So that's the traditional labs, as they're called, or homework. So yeah, homework assignments, things like that. Any questions as far as grading? How many of you have taken a machine learning course before? I know you 2 have. I know you. All right, yeah. So, but you've taken Intro to AI, so that covered a little bit, same ideas. You'll see it's consistent. This one is just more specific to the problem of the algorithms learning from data. Okay. All right, please read through these. These are, information here. The more important thing for me is just please submit your homework on time and on Brightspace. Okay, please don't send me homework via email, things like that. That's like my one request. All right, so just do your homework assignments on Brightspace. Usually what I need is some kind of a lab report. So think of yourself as writing a report for your boss at work, something like that. So I trust you guys. I don't need you to give me every little step that you follow, right? But really I need the results. I'll be able to tell if you did the homework just by the fact that it'll make sense, right? So it'll be some kind of data problem and you need to provide some performance metrics, things like that. So yeah, I need a lab report. If you want to submit your code and everything, you can, but always provide a lab report. Also, don't provide like 17 pictures. Put them in a Word document or PDF. So I have one single unit. Put some sentences in there, right, of your conclusions. Attendance, as I said, you do have to attend class. and then read through this, please. This is an idea of the topics that we will cover. So, yeah, today I'm almost finished with the syllabus here. So then we're going to move on to introduction to what machine learning is, some word problems, basic machine learning approach. But these are individual topics that we will cover: features and the vector space model, tensor operations. I'll probably start with that today, just to kind of get us warmed up to what this is about. Performance metrics, WECA in particular. You can see here, I like to start with WECA really quick. We'll talk also about setting up the software, which I think some of you get stressed about. We're not going to use VMs in this course. Instead, you'll be using essentially online things like Colab. All right, Colab actually can do pretty much everything that we need. WECA we will need to install, but it's very easy to install on Windows, etc. There will be, as I said, a WECA homework for sure, so I will be doing that. And then we'll get into some of the techniques. Feature ranking, singular value decomposition is a nice technique for recommender systems. So we'll talk about that. And you're all familiar with recommender systems, right? So when you go on Amazon, what happens? Amazon recommends a book for you to buy. When you go on Netflix, what happens on Netflix? It recommends a movie for you to watch, right? So this is one topic that I'll be covering this semester. And then a lot of the traditional machine learning algorithms, definitely KNN, naive Bayes will cover, decision trees, Hopfield networks. This is actually, this algorithm won a Nobel Prize in physics, I think like 2 years ago. So even though it was invented 20 years ago. So some of these things are pretty important. ML, then we'll have exam 1 on week 6. We'll have a homework called Perceptron homework, which will involve web deployment. So we'll look at deploying our models. So that one is going to be with Fast API. You can see here the same traditional ML algorithms. Then we're going to get into neural networks. As you can see, that's an important one. Like in 520, I don't start with a perceptron. In this course, I do start with a perceptron. So a little bit of more of like the history of it and how it evolves. So it's, the perceptron today is not considered something that you would use for anything really, but it does provide, a nice introduction to neural networks. It's the simplest, the first invention in the 1940s, right? So I'll provide also a little bit of history back then in the 40s of how how it came about. Backpropagation, the chain rule, so we'll talk about that. Cyber data sets, as you can see. Then we'll cover torch and some deep learning, and then ResNets, transfer learning, and reinforcement learning, and a few other special topics. All right, so that's the syllabus. Okay, so also read these emergency procedures, please, and so that's the syllabus. Are there any questions? So that kind of completes the introduction to the course, and now we're just going to get into, our first topic. No questions? All right, so let's get started then. Okay, so let's go back to content, table of contents. So that was admin. So send admin. Then, here's project, as I said. So we'll come back to this at some point in the semester when we're covering term projects. So the first thing we're going to do today, just kind of like a warm-up, okay? Just do something. This is actually important, but it's more background than anything else, all right? It's like every, you take a course in finance, right? And there's a set of math operations that you have to understand. Do you see what I'm saying? So like the time value of money when you took, some kind of financial class, right? So 1 plus something to the exponent, right? And that allows you to discount money. So you have to understand that math operation. So here's the same thing. We're going to look at a set of operations with Python, thankfully with NumPy, and just to kind of get started. So this allows me to set up the environment and we'll do something with it. Okay? So here I have this link under matrices, vectors, and NumPy called Tensor Operations. And I have about about 100 problems. There's 107, I think, problems. And so these are individual operations that we'll be doing as we start looking at the algorithms, right? So we'll be manipulating data, we'll be manipulating, converting data from one thing to another. So yeah, so these are the things that you have to become familiar with. My suggestion, I don't spend too much time on this, right? Because this could take me 3 to 4 weeks to go through all the problems. And I don't assign it as a homework either. But I do recommend that you practice these problems on your own. So yeah, sir. These are the exact same. Yeah, sorry about that. So you guys are experts. There's a little bit of overlap. Yeah. But yeah, so these are the same ones. Yeah. So go through these, okay, on your own. They're not homework or anything like that. Just practice them, and they should, help you out with the topic. So I'll show you what I mean. So let's start here with problem 1, right? And so this is code that we would be processing, okay? So the other thing that we're going to need is, obviously, we need an environment where we run this. So we're going to bring up Colab. So for this, you need to have a Gmail account. So I should be already signed in. So Colab. And this is your Colab environment, okay? So then you click New Notebook. All right, and that's it. This is from, like Jupyter Notebooks. I'm sure all of you have used Jupyter Notebooks. It's kind of like a Jupyter Notebook. The only difference with this one is that we do have access to a GPU, and that's really good. So if you go to the runtime, so first of all, I'll add a few cells here. So I'll add a few code cells. If I click on the runtime here and I go to change runtime type, I can select a GPU. Do you see that? And Google provides this for free for you to use. So why use a GPU? What's a GPU? You guys know this, right? So some of you have gaming PCs or something like that, and it's a graphics processing unit. It allows the games to run faster, right? So it's the same idea with machine learning. It allows you to train the models faster. If you only train them with a CPU, it might take 10 hours, whereas if you train a model with a GPU, it might take you 2 hours. So, you take your pick, right? So, especially when you're repeating, right? So let's say you do something and you realize that didn't work. Now you have to do it again, and that's another 10 hours, right? So at that point, yeah, you want to use the GPU. So you have a certain number of credits as a student, and you should be able to do, we're not going to be using GPUs all the time, so sometimes you can just use your CPU, but that's the advantage, the convenience. There's also other things that we can use, like Anaconda, so we can also switch to that and just use regular Jupyter Notebooks. Does that make sense, guys? This one is also easier because sometimes the libraries are installed very easily, right? So it's like, if the library may be there already, or it just installs very easily. All right, so let's take a look then at just some examples. Okay, so like I said, I'm just going to get you started with this. Play with it. I'm not assigning homework yet, but it's just so that you start to get familiar with the environment. We will be using this for the whole semester, okay? Because this is where we're going to write Python. All right, so let's take a look at the first problem. So I've got some libraries here. So these libraries are NumPy, import NumPy as an NP. I'm sure you looked at this one in 265 for something. So it's a very common, very powerful library. Import matplotlib.pyplot as PLT. This is for visualization, looking at plots and charts and things like that. And then import Torch. So we're not going to be using Torch right away. So Torch will come likely on the second third of the semester. But just as an example, I have this available, so you can click on the cell here to run, and then we should get a little green check here that says that it loaded correctly and it ran correctly, and there it is. So does that make sense? That's it. That's the environment. Any questions? Anybody having trouble with Colab? No? All right. So yeah, so that's what, so hopefully you've used it before maybe. So that's kind of the idea then. Um, we'll be using Colab for pretty much anything that has Python. It's just the most convenient way. And then later I'll show you how to bring in a data set. Essentially, we just mount the Google Drive on here, and then you can load your files on Google Drive. That way you can move them around, your own personal Google Drive, and you can just get them from there. All right, so let's just do a few examples here of how this works. Okay, so what I'm going to do here, as you can see, you probably study, this is probably a review for you from 265, but I'm essentially processing Python data. So let's take a look. So natively, Python has these lists, like a Python list. It's great, but for machine learning, it's not efficient enough. Do you see that? It's like here, because the data gets big, the neural networks or whatever get also complicated, we need speed. Okay? So we always need to use these libraries which have been built, which are optimized for operations. So what's happening here essentially is I'm taking a Python list and running it through this function mp.array. And essentially, it's not changing the data, but it's changing the underlying data structure. Do you see that? So it's the same data, but we're converting the Python list into a NumPy array. Yes, sir. Is that? Yes, this is, yeah, there is no PyTorch. It's actually called Torch. Yeah, yeah, very good. Yeah, and all this code, by the way, is coming from the link that I gave you here, tensor operation. This is not tensor. Okay, that's a great question. Yes, actually I like your question. So he mentions TensorFlow, and we're not going to use TensorFlow in this course. We're going to use PyTorch at some point later in the semester. But tensor is, mathematically, it has like a specific definition. For our purposes, it's just any array. So you're all familiar with arrays in programming. You've done one-dimensional arrays, two-dimensional arrays, three-dimensional arrays. There's four-dimensional arrays, and there's 1,000-dimensional arrays. You can have those, right? So they're just a data structure, and the common term for them is tensor. Do you see that? And so when Google created a framework for running these operations, they called it TensorFlow, because tensors flow through some computational graph. But there is an alternative to TensorFlow called PyTorch, which is what you mentioned, right? And so I like Torch way more than TensorFlow. It's just PyTorch. I believe it, and this is a common thing in industry. Like everybody likes PyTorch better than TensorFlow. TensorFlow can be a little bit more convoluted, whereas PyTorch is very elegant and simpler and just as powerful. All right, so we'll cover that, but actually not right now. As I was saying, this was just me introducing the libraries and everything. We'll cover more of Torch when we cover transfer learning and when we cover some neural networks later in the semester. But yeah, that's a good, it's like another confusion that I've seen over the years with IT students, that they confuse Java and JavaScript. You know what I mean? Like, and that makes sense. Well, don't confuse tensors with TensorFlow. We're actually not using TensorFlow or Keras. We'll just focus on Torch. But the term tensor is quite important, and I call this tensor operations, in fact. Is that clear for everyone? Yeah. Yeah. All right, and like I said, the reason being is because we're dealing with arrays most of the time, two-dimensional, three-dimensional. So in your programming courses, you've learned, every time they told you, do something with this two-dimensional array, 2 for loops, right? 3 for loops. and you're used to that type of coding approach. But that's a sequential CPU coding approach. That does not work for AI and machine learning because it's too slow. All right, so that's highly inefficient. And if you code it like that, I mean, it wouldn't even take 10 hours. It'd take 20 hours to do everything, right? So you have to learn how to do things faster, right? For parallel computing, for all that. And so that's where this comes in, these tensor operations. Make sense? So again, you have plenty of time to practice these because we won't really reach these topics until like the second, third of the class, but just complete all these exercises in your own time. It's not homework, as I said before, but I do strongly recommend that you do them, at least mechanically, and get a feel for them. Got it? All right, and so they're the underlying basic operations. All right, so let's keep going. So as I said, this is just Colab. We can use a GPU here, so now you have a GPU from week 1 to do all the things, and you will learn to appreciate having GPUs later on. I've had students in the semester that get the professional edition and pay a little bit so that they can, because they want to win the competition, right? Or they just become very curious of better models that are more resource intensive. So you have all of that. I think also Google's TPUs are available through this. All right, so as I was saying, the key concept to understand about all these libraries, although we'll be writing a lot of code from scratch, we're going to be writing it in NumPy usually, at least NumPy, if not Torch or NumPy or something like that. The first algorithm, KNN, which we'll probably touch on next week, could be written in like 30 lines of code with the traditional Python approach, or if you take a NumPy approach, we do it in 5 lines, right? So some of it is a little bit harder to understand in the beginning, but see, once you start practicing these things, you start to see how it works and things start to make sense, okay? So anyway, so we have a list in Python. So the first thing, we convert it into a NumPy array, and now we're going to print it. So let's see here. If I do just the Python list, it has this format. Look, it looks, you barely appreciate the difference, but this is what, it's saying it's a Python list. Now if I run this one and print A, you can see there's a slight difference, right? You see the difference? What's the difference? No commas, right? And just that simple thing is telling you that's a different data structure. Same data, but now by putting it in a NumPy array format, you can perform other operations, multiplications on vectors and matrices, so that you don't have to do for loops and things like that. Got it? All right. So yeah, so we're going to label this topic tensor operations, and it's something that, you should practice. All right, so that's one example that I can do. So here, basically the approach, as I said, I'll repeat this. Go back to table of contents. Pretty much everything through here is just a syllabus, the project description, the resource links, something called GPU Scholar that I don't use anymore, actually. We used to have our own GPU cloud here at the university, but Colab is so much better than... It's like, why use that, right? Just use the Google's. So let me GPU. So it's not confusing. So usually when I put things after the final exam as topics I'm no longer covering or something like that. All right, so the first module that you can see here is in fact this one, tensor operations. So what I said to you guys is you click on the link And that takes you to these to my GitHub where I have every about 107 problems. I do have some notes so you can read through it if you'd like. For now, I'm not getting too much into this because we don't need it yet. I might come back to this later in the semester. But for now, I just want to, as I said, just a warm up, right? So let's just start doing something with machine learning that's useful, getting you to see these operations and dealing with the code. So I did problem 1. Let's do problem 2. Just this one. All right, so just another simple example. Same libraries as you can see, so I don't have to repeat them. And instead, I'm going to grab all right, so now what I'm doing is I'm taking another list. Notice over here, this list from of 4 values, 1, 3, 2, and 5, and I'm converting it to a NumPy array as well. But this time, another thing that we want to learn about these libraries is that they're very verbose. And what that means is that you're always providing like a lot of very explicit information. So notice I'm saying D type equal float 32, right? So this is another thing in Python. You probably, when you learn your first, let's say you've taken the C course. So one thing about C is you declare the variables, right? We're all familiar with this, declaring the variables as float, whatever. Then you took Python and you're like, hey, I don't have to do that anymore. Well, because here you have to be efficient and you're dealing with very large data sets sometimes, memory management once again becomes important. Do you see that? So once again, we start using data types through the libraries. Okay? So you can see here I'm saying 1, 2, 1, 3, 2, 5, these values in the list. I'm converting them to a NumPy array, but also the data type now is being specified as being float 32. Could be float 64, float 16, etc. And that just makes the size smaller. When you have really large models, that's really important. Okay, so if you're deploying to a Raspberry Pi or something, right, that becomes very critical. Okay, so that's kind of what we're doing. You can see here it added the dots at the end, so that's just telling you that the variables are float. Make sense? Okay. Yeah, and that's it. So we'll do a few more of these. I think it's 3. So we have a little bit of time today, kind of just introduce all the topics. Yeah. So we'll do a few more of these, right? And then I will leave the rest for you to do at home, okay? Not as a homework, but I highly encourage you to do these problems. And I always say this, I've been doing machine learning for a long time, right? So I put together this set of problems because I think, this is the key to mastering all this stuff, is understanding these specific sets of operations. I've broken them down into just 5 to 10 lines of code, right? Very units, small units that you can just focus on, kind of understand how they work. All right. So this is one example. Let's do a few more. All right. So that's problem 2. So let's do problem 3. And this is, no surprise, a 2-dimensional array. Pretty much a lot of our data is always going to be these 2-dimensional arrays. Okay. So yeah, so it'll be something like this. So same libraries as before. Okay, you can see here. What is this? This is still just a Python data structure. Notice that a 2-dimensional array in Python is just a list of lists. Do you see that? Square brackets are lists, and within that I have this vector followed by this one, followed by this third. Do you see that? So this is a 2-dimensional array, but is still Python. So I need to convert it to a NumPy array, same data, different data structure. Okay, so that I can do some operations with it. And once I do that, then certain functions and methods, actions, etc., become available for this object. Okay, Any questions about this, guys? Pretty easy, right? So, yeah. Okay. So let's do problem 3. Okay. Problem 3. Did I click on this? Yeah. Oh, sorry. That was problem 3. Problem 4. Right. So also you can create your own vectors and matrices instead of giving like the data. There are built-in functions that help you to do this. So for instance, and we'll be using these things, as I said, when we get into KNN and the perceptron and all those algorithms. uh, you'll see all these different tricks, right? And so that's the idea, that some of these things that are going to come up in those algorithms, I'm showing you first here as standalone units. So here I'm creating via NumPy a vector of zeros of size 10. Okay, so this should have 10 elements and they're all 0 because of this. And the data type is also integer. So I click on this and now you can see there's 10 of them, right? They're all 0, they're integer. And they're a NumPy array. Okay, so let's do a few more. So that was problem 4. Let's problem 5. All right, so let's do another one here. So this is NP ones. So instead of NP zeros, so at least I'm creating a whole bunch of ones. This is a two-dimensional matrix, which is 4 by 6, which later on we're going to learn that 4, the rows, essentially means the samples, and 6 means the values. So this is something else that we need to start to understand, right? So for instance, let's say that I had images. So I have 4 images and I have for it each image is represented by 6 values. So that's kind of what that's going to mean as we go forward. Okay, and then the data type here is float. So then when I print it, you can see it's 4 rows, 6 columns, and it's all ones, and they're float type. Got it? So we can create data very easily like this. All right. Um, problem 6. Problem 6, similar. So NP full, this just creates a specific value that we want to specify. In this case, it's going to be the number 42. And this is going to be a 3 by 3 matrix. Do you see that? So there it is, 3 by 3. We can also print out the shapes of things. That's going to become helpful later on. So this is b dot shape. Three by three. Not sure why it took so long, but 3 by 3. Right? So you can see it gives you this, idea. This is important later because obviously when we're dealing with data sets of 70,000 images by 784 values, you won't be able to print them, but you can look at sections of it and you can look at the dimensions. So that's problem 6. You see how simple it is. Obviously, these problems do get harder. And like I said, you don't have to master everything. The most complicated topic of these is going to be something called, what does it go? Forgot the term. Sorry. I forget. It slips my mind right now. But anyway, so that will, we'll cover that later in the semester. Don't worry about it right now. But there will be some more complicated topics here as you progress. All right, so that was problem 5, I think. It's 5. Problem 6, we did that too. Problem 7. All right, so let's do this one. This example just shows you the capability with NumPy. So here, I'm using another function called arange. You'll see me do this a lot as we start going over the algorithms. I may be creating a data set, etc. And so I'll use functions like this. So arange creates a range of values from 1 to 30. So you can see that here. I run it, and it goes from 1 to 4 to 7 to 10 to 13, all the way to 28. So it goes from the range of 1 to 30, skips with a step of 3, right? And it just creates this data set for us for whatever reason, right, that we might need it. Okay. Broadcasting, sorry, in my mind I've been searching for that word. So the topic is broadcasting. Of these 107 problems, without a doubt, the hardest topic is something called broadcasting. And there's a few examples of that. Try to go through it mechanically. Later in the semester, I will cover broadcasting, as that's an operation that is pretty important. Very powerful, right? Very powerful. It's an example. For instance, you have 150 images, and you need to multiply them times one specific thing. So instead of having 150 times this and then 150 times the 7 times the same, right, 150 times, you just do 150 times 1, but you broadcast it. So it's a much more efficient operation. Okay, so we'll see that later. All right, so we did this example. That was problem 7. Let's take a look at problem 8. Mate. All right, so this is linspace. This is another little trick that I'll be using throughout the semester. And it's just functions, as you can see by what I'm doing. It's just simple functions from NumPy that allow us to create data. So here, NP linspace, 0 to 1, and I want 20. So you can see here, it basically provides 20 values in the range from 0 to 1, and it figures out the step in this case. Okay, and this is yet another type of operation where we can use the data. Let's take a look at problem 9. Random, that's another one. For those of you that have taken 350, we probably used this before. It's similar. So from NumPy, you can create random values, right? So here I'm going to create random values in a matrix that should be 4 by 4. So you can see that there. Okay, so this is 4 rows times 4 columns, and these are random values. You can create random values from a distribution, so that's also possible, and that actually starts to become important in some of the problems that we need to do. So let's take a look. Problem 10. So this one, notice it's a little bit different. Here we use random.random. In this example, I'm going to use np_random.normal. So what that means is I'm going to create random values, but they're going to follow something called a specific distribution where the mean is 0 and it has a standard deviation of 1. So it's a normal distribution, right? Like that, 0 mean. And this is, again, important in some context. So you can see that np.random.normal 0, 1, and it's going to be a 4 by 4 matrix. So now these values, although they're also random like these, you can see they have a different, these are all positive, these go from positive to negative because they're in a mean of 0, so they can be on both sides of that. Does that make sense, guys? So again, these are just tricks on creating data, on doing these operations. Obviously, later as we look at algorithms, we'll say, well, we need to use an NP random.normal distribution for this type of problem. And there will be reasons why that's better. Okay? So that's the idea. Okay, so that was problem 10. So we've done 10 out of 110 problems. Not bad, right? So we can finish. I'll do a few more of these, and then we'll talk about the next tool that we will be using on Wednesday, which is the Weka tool. All right, and for that one, I'll really kind of just introduce it, and then you guys have to install it and have it available on your computers on Wednesday. Okay, so we'll talk a little bit about that. But let's finish a few more of these. So this was problem 10. Let's do problem 11. All right, so here's just, more operations. I'm going to take another function called the identity matrix np.I of size 5. You can see, and all that happens here in this one is what? Basically, on the diagonal, it's going to be all 1s, and otherwise it's going to be 0. I can tell you right now, this becomes really important when we start looking at singular value decomposition. All right, so we'll be looking, and that's, like I said, a nice topic because it'll relate to recommender systems. Okay, so I'll show you guys some very simple ways. And you collect data, for instance, an example of movies. So we'll have users, we'll have movies, and people say, I like this movie, I give it a 3. This movie, I give it a 4. This movie, I give it a 1, and so on, right? So that's going to be collecting the data, and then we're going to learn how something like singular value decomposition can be used to essentially, organize the data, process the data, and from it to start to build recommendations. But one of the matrices that's going to be in singular value decomposition will have this shape, all right? So it's important to understand where these things are coming from. All right, so that's an example here of that. Let's create another matrix here in this example. So I have this one. If I do the shape for n dot shape, you see that it is 2 by 3. Okay. So another thing that we have to understand is that sometimes we have these matrices where we have row vectors, 2 row vectors, and we need to convert them into a format where we have actually the same data, but they're 2 column vectors, right? So instead of being 2, 3, maybe it needs to be 3, 2. Do you see that? So this is just some of the operations that we might need in the future. So mechanically, we could do that like this. Right, so I can take that n, which is, it looks like this, and it is 2, 3, and just perform an operation called a transpose, np.transpose. And then now, notice that it no longer looks like this, it looks like this. So I made 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. Does that make sense? So just an operation. Think of it like, when you were learning algebra or something, right? An operation. So here, but later on in the context, I might say, you know what, for this, we need the transpose of it. So let's just flip it. If I print the shape of this, you'll see that P underscore TRA dot shape, it is now 3 comma 2. Same data, but reformatted it a little bit, and that's going to be helpful for some operations later on. Any questions? Okay. So why does this work? Because, just like we have algebra, and it's a set of operations that you studied in high school, right, and you very well, there's something else called linear algebra, right? And in linear algebra, you have a special set of operations that work in this space of vectors and matrices. But as I said, it's simple things like knowing how to flip things. That the official term for this is called a transpose. Okay, but that's it. It's just an operation. All right. So let's do a few more. And then that'll be it, by the way. After that, the rest you do on your own. So my recommendation, I'll say this right now, I'll repeat, no homework this week, right? But instead just try to go through all these problems. Okay, doing the first 15, then move on to 16 to 30, 31 to 45, and so on. And they're about the same size. Some of them get bigger, all the way, and just complete all of them in these, at least mechanically. Right? Try to understand them, of course. You don't have to submit a report or anything, but just practice them. And I do think they will help out as we progress throughout the semester. Any questions on that? Yeah. All right. So go through those. So we did the transpose. Take a look here. Problem 10. We did that one. Did this identity one. And this was where the transpose is. So that's certainly an important operation, the transpose. Problem 12. This is a simple one, I think. Just creating random int values. Yeah, so this is just creating integers randomly. So I think that one's an easy one you can do on your own. Let's do problem 13. So this is indexing, selecting values from an array. So let's try this one. So sometimes you will need to get values, maybe, when we do KNN, right, we're going to have a sequence of answers, then we need to rank them, and then we need to pick the top 3, right? And we need to do that efficiently, right? So we're going to need to understand how to do indexing and slicing from NumPy arrays. So this is indexing. You can see here I'm creating an array with 1, 3, 2, 5. I can print A. Okay, print A, right? Have the values. And then I can do something like just selecting the first one. So this is indexing. So essentially I just grab this first one, right? So 1. See that? I can, if I want to pick the last one, sometimes what we need is actually the last value, but we don't know how many, what that value is exactly, the size of the matrix, etc. So if you just use -1, it essentially grabs the last one. Okay? So this would be the number 5. You see that? So that's, very common thing, using -1 as the index to obtain the last element. If I want the before to last, then -2. So this should give us 2. Do you see that? And it does. Make sense? Again, these are just like very little operations that the problem is I'm doing an algorithm and there's like 7 of these operations. And if you haven't seen them before, it becomes, a lot, right, to understand everything. But I'm breaking it up into these single units so it's a little bit clearer. All right, so we want to grab the second one, that's 2. All right, so let's do a few more minutes. Let's All right, so that was problem 13. Let's do problem 14. So this would be same thing. Actually, we can skip this one. You can do it on your own. Essentially here, obviously, it's an array, a two-dimensional array, a matrix, right? So I need to use both the index for I and the index for j. So I need to say a 0, comma 0. That should give me 1. And if I want, so for instance, now this is where it gets a little bit complicated, right? So I could give you this problem on the exam. I give you this, and I give you this, and I say, what's that value? You see what I'm saying? So what is that value? Well, 2 means the row number 2, so it starts at 0, so it's going to be 0, 1, 2, and then minus 1 means what? The last one of that one, right? So that's why it should return the number 12. Do you guys see that? So yeah, you just have to become familiar with these little tricks. Indexing and slicing is actually very important, okay? Because you will be getting data like that. Sometimes we have all the data, including the labels. We have to take one column as labels and the rest of the data as another matrix. So we have to separate them out. All right, so that one, I do recommend you do practice this one on your own. The next problem should be, I think, 15. This is the last one of this batch. Okay, let's take a look at this one. Oh, this is really important, actually. This is called slicing. We're going to start with some simple slicing, but definitely something that you'll be using a lot. So let me get here. All right, so I'm just going to create a simple NumPy array with 15 values. Okay, so there it is. It goes 0, 1, 2, 3, all the way to 14, right? And the idea is just we're going to play with this and figure out how to do slicing. Okay, so for instance, in the first example, I want the first 4 elements. Okay, so how do I slice that out? Well, I use this format. I grab the vector x, the NumPy array x. We use this colon to indicate range. If we don't specify a value here, it just means from the beginning. And then we say until index 4. Do you guys see that? That's it. So that's the first 4 elements in slicing. So that gives us 0, 1, 2, and 3. And remember, it always starts at 0. So just be aware of that. Now let's do kind of another one. So now I want all after the third index. Okay? So now I'm coming here and I'm saying, okay, is this the third index, right? Well, if it starts at 0, 1, 2, 3, or is this the third index? So anyway, we're saying x from 3 index colon range until, if I don't specify anything here, it means until the end. Okay? So that's essentially what that means. And so this grabs from 3 all the way to 14. Do you guys see that? And so that's another way of slicing. Obviously, we can slice from two-dimensional matrices, so that is probably problem 16. But let's finish this one first. All right, now let's take even indices. Okay, so notice I'm not specifying anything, so I'm just saying from beginning to the end, right? But space by 2. Do Do you see that? So that grabs all the even ones, right? So it grabs 0, 2, 4, 6, 8, 12, 14. Does that make sense? Yeah. All right, so what if we want uneven indices then? How could we do it? Even indices are these, right? So uneven, how would you change this one? We have it here. We just add the starting point. Before it was starting at what? 0. So it was grabbing all the even ones. So now we start at 1, 1, 3, 5, 7, 9, 11, 13. Make sense? Yeah, so these are the little tricks that you have to master when dealing with NumPy. The nice thing about this is that like PyTorch is really like just trying to copy NumPy, to be honest. So there's a lot of consistency. Sometimes like the words change a little bit, but the intuition is almost always the same. And so a lot of these operations that you learn in NumPy, because we will be using NumPy a lot this in this course. Um, and it's very powerful as well, but just it will be consistent once you move up to more advanced. Let's say you continue to learn a lot about machine learning, right, by taking other classes. So PyTorch and even TensorFlow would be very consistent to NumPy. Okay. All right, so we did problem 15, I believe. Have we finished it? Oh, this one is interesting, actually. And this is one that I don't necessarily will know. And I understand that you guys will probably ask ChatGPT how to do some of these things, and that's okay. But yeah, this is a reverse one. So essentially, the range is from beginning to end, but notice we're saying -1 here. And so the step value, the meaning of this is that the step value is negative. So it starts at the last element. So that's one that I don't always necessarily know, right? But if I look at it, it kind of makes sense to me. So here at 14, 13, all the way to 0, just in reverse. I could give you a problem where I ask you, okay, here's an array, put it in reverse. And, how do you do that, right? It might seem like pretty hard, but if you take this approach, it's one line of code. You see that? So that's the advantage of this. Making, instead of reversing this with like a function and 15 lines of code, you just do it with one line of code. So the code, the workload is less essentially. All right. So now, and then this one, oh yeah, we did do the other thing. So that. All right. So that's the first 15 problems. Right. And so you get the idea. So then, what you would do is you move to the next batch of problems. So that's going to be 16 to 30. You see that here, 16 to 30. Okay. So this is slicing, but two-dimensional matrices. So this is important actually because, like I said, just dealing with the data, as we're going to be getting data, we'll need to efficiently load. Usually we'll load the data with pandas. That's essentially what we're going to do. We'll have some CSV, load the data in pandas, and then that's going to be a data frame. You probably looked at pandas in 265 already, so you have at least an introduction to it. And then from pandas, we will convert it into a NumPy array. And that's your data that you need to process before you move it into a machine learning algorithm of some kind. All right, so let's take a look at, didn't copy it. Yeah, so let's take a look at this one. I thought I'd copied it. We're going to be doing slicing, but on a two-dimensional array. So let's take a look. So this is the NumPy array. There it is. So we have a matrix that is 3 by 4. Okay, 3 by 4. And now what we can do is we want to slice out just this section, 1, 2, 5, 6. Do you guys see that? Or possibly actually, yeah, let's see. It could be also 1, 2, 3, 5, 6, 7. So what you do is you take the matrix A and you just remember that because it's a two-dimensional array, it has an I comma j, right? So it has two indices. So for I, it's going to be from what? From the beginning to index 2. And for j, it's going to be from the beginning to index 2. Do you guys see that? And so in this case, yeah, so it excludes index 2 in this case. So it only grabs 0 and 1, 0 and 1. Do you guys understand? Make sense? All right, so now I give you a problem. Let's imagine that the labels are 4, 8, and 12, and the data is 1, 2, 3, 5, 6, 7, 9, 10, 11. So essentially, I need to create two matrices, a matrix and a vector from this one, right? So I need to slice out, essentially, the first three columns into one thing and the last column into another thing. So how would I do that? So let's call it X, right? X. And I need to grab from A just, like I said, 1, 2, 3, 5, 6, 7, 9, 10, 11. So who can tell me? How do I do that? How do I slice that out? And then later, I'm also going to slice out J, or Y, sorry, X and Y is going to be just 4, 8, and 12. So I can just slice that out as well. So how do I do it? Do you guys understand my question? Any suggestions on doing this? Yeah, please. It's A, right? A. X equal A? Yes? So
instead of
okay, we're going to slice it from here. All right, so A square bracket, okay?
and then colon and whatever you want to point out.
Right, so for X is 1, 2, 3, 5, 6, 7, 9, 10, 11.
So just do 5
Negative 1, okay? That's it. Okay. Didn't work though. Because you're supposed to get 1, 2, 3, 5, 6, 7, 9, 10, 11. But good try, right? At least you're showing that you did slice something out. So we just have to change this, okay? So maybe we should have I and J, right? So this would slice the whole thing out again, right? So obviously we don't want that. Do we want all three rows? Yes. But we just don't want the last column, right? So what if we do that, possibly? What do you guys think? Let's try it out. That's the best way to understand this, right? Is just to try it. So, oh, there we are. So that gives me 1, 2, 3, 5, 6, 7, 9, 10, and 11. You see that? So I'm able to slice out the data. Now let's slice out the last column, which is going to be what we're going to call the labels. So let's say that's Y. Y. So how do I do that? The same thing. I get A, and then what? What would you guys suggest? I need the last column. So that means I need something that only has 4, 8, and 12. How do we slice that out? 4, 8, and 12. We need 4, 8, and 12, which essentially they're in all three rows. So we need kind of all three rows, maybe. But we only need the last column, right? So maybe -1 here, as you were saying. That kind of makes sense. 4, 8, 12. Do you see that? Do you see how I extracted 4, 8, 12 here? Here I'm using the -1, right? That trick. I'm using this idea of slicing. And like I said, this is the kind of thing that you're gonna have to practice. So you practice this over and over, and eventually you'll know that you can use it, and then you just do a couple of tests until you get it right. So let me plug in my chart. Right. So, I've been doing this for a while and I wasn't sure 100% that that was going to work. Right. So I kind of, and that's what I want you guys to understand is you kind of know what you have to do, but just try different indices until you get the right one that works for you. Right. That's essentially what you have to do. So you don't have to memorize anything here. Just understand kind of the basic idea of it. And then, like I said, try -1. If that doesn't work, try a different kind of a range. I could have also tried, so for instance, for this one, I could have done two, or sorry, maybe three, four, just as an example, right? So let's see, that's from column index 3 to column index 4. Okay, that also worked, 4, 8, 12. Do you see that? And also notice there is a big difference here. When I did the other one, and I deleted it, I guess, but let me, so y a, what was it, like this, right? -1, and let's call it y2. When I run this one, it's still the same values, right? So it's the same data, 4, 8, 12, 4, 8, 12, but they're actually different data structures. And that's important to note because one is going to be 3, 1, the other one is 1, 3. So that gives you a bit of a problem, right? But I already showed you that there's an easy way to solve this, right? You can just use the transpose. So if we do y2 transpose, which was np dot transpose, sorry, of y2 didn't transpose it. Let me print the shape actually. This is y2 dot shape. Right. Okay, so that's 3. That's the issue. Okay, so that's why it's not working. So this is another problem actually. We have to make it 3, 1. Do you see this? This is only 3. So that's actually another operation that's coming up. So here, if I do this one, y2 dot underscore transpose dot shape. Yeah, so they're both 3 comma. They need to be 3 1. All right, so yeah, we're almost out of time for today. So I will continue this on Thursday, but you can look at it. So you can see we covered problem 16. If we get into future problems 17, etc., we're going to look at different ways of adding dimensions and things like that. So I'll continue with some of these on Thursday. But before you leave, the other thing we need to do on Wednesday is I need to introduce this tool called Weka, right? So what I want you guys to do is just to have it installed for the class on Wednesday so I can do the demo of the tool. So the tool is very easy. Just on your Mac or Windows or whatever, you can easily install it. So it's called Weka here. just like that. So go on there and download. Oh, there it is. Download. Yeah. And so software, right? Okay, yeah, download. Do you guys see this? And you click on that and installing and everything, Windows. So you click on that or Mac, or I'm sure they have all that. And please install this tool. Does this make sense? So let's say it should be just a, like a wizard or something that you follow. Once you've installed it, I already have it on my machine. So it should look like this. Weka, you click on the app, and it opens. It's like a little bird. This was built in New Zealand, but it's a very nice tool, actually. It's been around for a long time and it still works well. And there it is. So you should, if you've installed it successfully and correctly, you should get this menu here. Yeah, this menu here, and then you click on Explorer, and then it'll open up this tool here, this screen, okay? So just make sure you're able to get to this on your computer by Wednesday, and then my demo will start here. I'll have a few data sets, and then I'll show you to do some machine learning on this tool. Got it? We'll also continue some of these tensor operations on Wednesday, just kind of as a review, and that's it. All right, guys, so welcome to 365, and I'll see you on Wednesday.